Hello, and welcome to this section of the course where we're going to continue building our skills and really conquering the topic of algebra. So in this section, we're going to kind of give more of that foundational material, and here we're going to review everything there that's really important to know about dealing with fractions. And I'll tell you, from all of my years of doing this, fractions is one of the things that gives people the most trouble, but in fact, it's one of the easiest things to do once you know how to do it. It seems like there's a lot of rules to remember and a lot of things to do, but with practice, it will all become clear. Now, what I want to say here is that we're going to cover in this section how to simplify fractions, how to add them, how to subtract them, how to multiply them, and how to divide them. We're also going to talk about mixed fractions and improper fractions. So we're going to cover quite a bit of material in this one section. The pre-algebra course that we have, the course just before this one, has even more material with fractions. So if you think you need more of a refresher on that, then go take a look at those videos and they have even more. So what we're going to do here is give you enough of a primer so that whenever you get into later on into algebra, you've got such a good confidence with your understanding of fractions that when you see a fraction later on that might have variables, that it won't worry you so much because we've already gotten such a great foundation. So what is a fraction, first of all? It is basically telling you or a way for you to mathematically express when you have something less than 1. I mean, we all know this, but when you get into the nuts and bolts of it, it seems difficult for a lot of students, including me, by the way, when I was younger. But if you have a candy bar, right, that's one candy bar, a unit of 1. If we break it in half, we have 2 pieces of that candy bar, right? But we still have 1 candy bar, it's just that we have 2 pieces now. Now, if I give you a piece, 1/2. 1 piece I've given you out of the 2 whole pieces that we have. So fractions are really invented so that we can express numbers that are less than 1. In this case, I've given you less than a candy bar. I've given you 1/2 of a candy bar. So that's why they're so important. But let's not forget that that is what fractions are really about. Now, the first thing we want to talk about is how to simplify fractions. And this is really where a lot of people not only don't quite understand how to do it, but they don't understand why we do it. So I'm going to try to go ahead and make this really simple with some everyday examples. So let's say we have the fraction 6/12. What does this mean? It means that I have something, I've cut it up into 12 pieces, okay? But I've given away 6 of those pieces to someone else, right? To someone else. So if you think about it for a second without doing any math, if I have a pizza and I cut it into 12 pieces and I give you 6 of those pieces, how much pizza do you really have? I mean, think about it. If I cut it into 12 and I give you 6 of them, I've given you half of that pizza. So we know this to be true from everyday experience. You have just, without realizing, simplified your very first fraction. You've changed it. Because what we've basically shown is that 6/12 of a pizza, 6 pieces out of 12, is the same as 1/2 of a pizza. So let's go and investigate why that's the case. If we want to simplify fractions, that's what we're doing. We're trying to rewrite that fraction into the simplest possible terms. So all you do to do that, anytime you're given a fraction and trying to simplify it, is you try to divide the top and the bottom of this fraction by some number. You can pick any number you want. But what you're trying to do is divide into the top and the bottom so that it will go an even number of times. So when I look at 6 and 12, the very first thing that I say to myself is I know I can divide 3 into the top and to the bottom. All right? You might pick a different number. I'm going to go ahead and pick 3. So let's say I have 6/12. What I'm telling you is that you can divide the top by 3 as long as you divide the bottom by 3. This is the number one thing with fractions that you have to understand and to realize. You can do anything you want to the top of a fraction as long as you do it to the bottom of a fraction, as far as multiplication and division goes. I can divide the top by 3, and I can divide the bottom by 3. Because I'm doing it to both. You can think of it as a seesaw. If I've got 2 kids on a seesaw, right? One little kid's over here, and the other person is on the other side. They're perfectly balanced because they have exactly the same amount of weight, okay? Now, if I take a bag of sand and put it on one kid's lap, the seesaw is going to teeter that way. But if I go take exactly the same weight of sand on a different bag and go put it in the other child's lap, the seesaw will be balanced again. Because I'm doing the same thing to both sides of that seesaw. It's the same thing with fractions. I can divide this by 2 if I want to, as long as I divide the bottom by 2. I can divide the top by 4. 4 if I want to, as long as I divide the bottom by 4. I'm not changing the fraction, I'm just changing a little bit the way that it looks. So when I do this, what is 6 divided by 3? 6 divided by 3 is 2. What is 12 divided by 3? 12 divided by 3 is 4. So I have reduced this fraction from 6/12 to 2/4. And what I submit to you is that 6/12 is exactly representing the same amount of pizza, so to speak, as 2/4. I mean, if I cut a pizza into 12 pieces and give away 6, that's half a pizza. If I cut a different pizza into 4 pieces, just in quarters, right, and I give away 2 of those pieces, then I've given away half the pizza. So I'm still talking about half a pizza. It's just that they look a little different. These two fractions are exactly equivalent to one another. They just look a little bit different. But if I notice, I can actually simplify this one even further because I look at 2 and 4 and I know I can divide it by 2. So I can divide the top by 2 and I can divide the bottom by 2. Okay? And when I do that, what is 2 divided by 2? That's 1. What is 4 divided by 2? That's 2. So here I've arrived at my 1/2 that we've been talking about this whole time. What we've proven to ourselves is that 6/12 is really the same as 2/4, which is also the same thing as 1/2 in terms of if you actually cut something up. If I cut something into 2 pieces and give 1 away, it's the same as doing these other things. That's what we say we're doing when we simplify fractions. We're given a fraction, it represents a certain amount of something. All we're going to do to simplify it is divide the top and the bottom by whatever we can, whatever we want to. Right? As long as we get nice numbers that come out, whole numbers is what we're trying to do until we get down to the lowest we can possibly go. We can't simplify this anymore because there's nothing else I can divide by to make it any simpler. So if I want to represent this, just to kind of drill it home in terms of a pizza, let me cut this pizza into 12 pieces, or do my best. Okay, there's some pieces there, some pieces there, some pieces there, some pieces there. 1, 2, 3, 4, 5. And one more right there. So let me count pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 pieces of pizza I've cut this guy into. Now I'm going to give away 6 pieces. So here's 1, 2, 3, 4, 5, 6 pieces of pizza. I've given that much away. Sure does look like half of a pizza, right? Well, if I come over here and represent 2/4, I cut the pizza into 4 pieces, 4 equal pieces. I give away 2 of those pieces. Here's 1 piece, here's another piece. I've given away 2 of those pieces. So now I've given away, again, half of the pizza. And then finally, if I come over here, this is the easiest. I cut the pizza into 2 pieces and I give away 1 of those pieces. So when you look at this, you can see visually that 6/12 is exactly the same amount of pizza as 2/4, which is exactly the same amount of pizza as 1/2. So keep that in mind as you simplify fractions, that it's really just representing the same amount of stuff, in a little bit simpler manner. So they're all the same thing. So you can do whatever you want division-wise, top and bottom, to simplify a fraction. Now let's go and work a few of these guys to give you some practice. What if I have the fraction 15 over 20? 15/20. That means I cut something into 20 pieces, and I give away 15 of those pieces. Let's simplify that. What can I divide into the top and the bottom? When I see 15 and 20, I know that I can divide by 5. Now I can write it in the top and the bottom, no problem, but I want you to get in the habit of not doing that all the time, so I'm going to kind of write a reminder up here that I'm dividing by 5. What is 15 divided by 5? 15 divided by 5 is 3. What is 20 divided by 5? 20 divided by 5 is 4. So I've arrived at 3/4. Now I should always look and see, can I simplify this any more? And there's nothing else I can choose to divide into 3 and 4 to make it any simpler, so this is the answer. 15/20 of a pizza is exactly the same amount as 3/4 of a pizza. If I were to draw these pictures again, make 20 pieces and give 15 away, and then represent this, you would see visually that it's the same amount of pizza. So simplifying fractions is really, that's all it is. It's basically rewriting how it looks, but making it a little simpler. What if I have 24 18ths? So let's say 24 18ths of a pizza. What numbers do you think of when you think of 24 and 18? You might come up with something different. I think of 6. I know I can divide by 6. So what is 24 divided by 6? That's going to give me 4. Because 6 times 4 is 24, right? What is 18 divided by 6? 18 divided by 6 is 3, so I get 4/3. So that is the reduced answer, 4/3. Okay. Now you might choose a different number here, so you should always just double check your answer is fully simplified, that you can't go any farther. And if you've gone as far as you can, then you just stop and circle it. What if I have 72 over 64? Right? Well, when I look at 72 and 64, you might ponder that one for a few minutes, but that, you should remember that you can divide by 8. What is 72 divided by 8? That is 9, because 8 times 9 is 72. What is 64 divided by 8? That's 8, because 8 times 8 is 64. So 72/64 is exactly the same thing as 9/8. So that's about as far as I want to go in simplifying fractions. One thing I want to tell you is don't get so worried if the top number is bigger. 4/3 and 9/8. All this means is that I cut a pizza into 3 pieces, but I actually gave away 4 pieces. Doesn't really make a lot of sense at first, but what it means is I actually gave away more than one whole pizza. If I cut a pizza into 3 pieces, but yet I dish out 4, it means I gave away all of those 3 pieces, plus I had to go cut another pizza up and give away another piece. So when you have a bigger number on top, it's called improper fraction. And toward the end here, we're going to learn a little bit more about that. So just hang on for that. But I just wanted to let you know, don't worry too much about having a top number bigger on the bottom or whatever. Right now, we just need to really focus on how to simplify these fractions. And you always do it the same way. Try to divide the top and the bottom by the same number to get your fraction simplified. All right. Now, most books will teach you how to add and subtract fractions next, because it makes sense that addition and subtraction is easier than multiplication and division. Well, actually, in terms of fractions, multiplication is actually easier. And division is actually easier, believe it or not. So what we're going to do now is work on multiplication of fractions, and you'll see how incredibly easy it is. And then we'll do division, and then we'll go on and do the addition and subtraction. You'll find out that none of it's really hard, but it's actually easier to do multiplication than anything else. So let's work on that right now. What if you were to multiply 1/2 times 3/5? All right. So all you do when you multiply fractions, it doesn't matter what these numbers are. It doesn't matter top numbers, bottom numbers. All you do, multiply the top number separately to get the new top number. Multiply these bottom numbers, these are called denominators, to get the new denominator. So 1 times 3 is 3. 2 times 5 is 10, and that's it. You look at your answer and you see if you can simplify it, but there's nothing I can divide into these to simplify it, so I'm done. 3/10. Multiplication of fractions is just that simple. You don't do anything else but this. 4/3 multiplied by 6/5. All you do is multiply the top. 6 times 4 is 24. 3 times 5 is 15. And you always look at it and see, hey, can I simplify this fraction? And in this case, I can, because I know I can divide the top and the bottom by 3. I'll write that reminder to myself. 24 divided by 3 is 8, because 8 times 3 is 24. 15 divided by 3 is 5, because 5 times 3 is 15. So I have 8/5. So what I'm trying to say is when I multiply these fractions, this is the answer, but this is also the answer representing exactly the same amount of stuff. It's just written in slightly simpler terms. Not quite as big of numbers, but it represents the same amount of material. Okay? Well, let's go and do something different a little bit here. Slightly different anyway. 5/12. Let's multiply that by 18/5. All right, now, using the same pattern as before, we could just take 5 times 18 and get the new answer on the top, and do 12 times 5, and that would be 60, and that would give us 60 on the bottom. We would have our answer. We could try to simplify it. That is always correct. You're never going to go wrong by doing that. You can always just multiply the top, multiply the bottom, and there you go. However, it's very important for us to introduce some other ideas now, because when we get in later in algebra, you'll be using them over and over again. Anytime you have these things multiplied like this, if you have sort of like a common term on the top that's also on the bottom, it doesn't matter where it is, because these are all going to be multiplied together anyway. But if you have it on the top and on the bottom like this, then I can simply strike through them and sort of cancel them out. Now really what you're doing, you're not really canceling them. They're not really disappearing. It's just that what's really happening here is, if you think about it, let's do a little bit of an aside here, and you'll see why we're doing this. If we were to do this, it would be 5 times 18 on the top, but then we would be dividing by 12 times 5 on the bottom. So ultimately what we're doing here is we're multiplying by 5 on the top because of this 5, but then we're going to turn around and just divide by 5 again. So we've multiplied by 5 on the top, but then we just divide by 5. So, it's just like taking, what if we take 1 times 2, right? That's going to give us 2. Right? And then we take 2 and then divide it by 2 again, this answer, and divide it by 2 again, and that's just going to give us 1. So the 2, the fact that we multiplied by 2 and then we divided by 2 really disappears. We end up with the same number that we started with. If you take 3 and then multiply by 4 and then just turn around and divide by 4, then the 4s really don't do anything. They basically disappear because you've multiplied by it and then you divided by it. Well, that's exactly what we're doing here. We're multiplying by the 5, but then we're dividing by the 5. So in fact, they really kind of disappear. And really, if you want to really be technical about it, they don't really disappear. It's just that they're dividing out. 5 divided by this 5 on the bottom is getting a 1 here and a 1 here. So in other words, you can think of it any way you want. You can think of them disappearing because of this cancellation, but you can also think of them as disappearing and leaving a 1 behind because they're dividing out from one another. Now let me also show you something else that we can do in this fraction to simplify it. We could now at this point take 1, because this 5s are gone now, we could take this 1 times the 18 and get a new numerator, 12 times the 1 and get a new denominator, and then we could simplify that. That's also possible. But we can actually simplify more ahead of time here because this is all multiplied together. Notice that we have 18 and 12. Okay? Can I divide both by something to make it simpler? Well, I can divide this guy by 6. I can divide 6 into 18, and I can divide 6 into 12. So when I divide the 6 into 12, 12 divided by 6 gives me 2. So I scratch that out with a single line and put a 2 there. 18 divided by 6, I put a line and I say 3. So what I have done is totally simplified this fraction. Let me continue on and we'll come back and go over this part a little bit more. All of the big numbers are now gone. We have a 1 times a 3, giving us 3. We have now a 2 left over times a 1, giving us a 2. And this is totally simplified, 3 halves. So I want to make absolutely clear, if you didn't do any of this simplification, 5 times 18 would give you a big number on the top. 12 times 5 would give you a big number, that's 60, that would be on the bottom. But see, then you would have an answer that you would definitely have to simplify again, right? You'd have to divide by top and bottom, and you have to get it down into simplest terms, which would give you this answer, by the way. All we're doing is we're doing the simplification ahead of time, so we don't have to deal with the big multiplication. We're looking at the 12 and the 18, and we're saying, hey, I can divide both of those by 6. 12 divided by 6 gives me 2. 18 divided by 6 gives me 3. So I mark them out with a single line. Don't scratch it out. Just mark it out and write those numbers down. Okay? And then notice I explained that these are kind of canceling, but it's really the same thing. I have a 5 on the top and a 5 on the bottom. So I can think of it, if I want, as dividing by 5 here. That gives me the 1. Down here, I'm also dividing by 5, giving me the 1. So again, I'm doing whatever I want to the top and the bottom of these fractions as long as I'm consistent. Divide by 6, divide by 6. Divide by 5, divide by 5. When I do that, I get new fractions that are much simpler and that can be readily multiplied. I didn't have to pull out a calculator to do this multiplication. I just get the answer directly. Okay? So what we're going to do is just keep on working a lot of problems here. If this idea is a little foreign to you, don't worry about it because we're going to do a lot of these things and it will become very clear. What if I had 17/34 multiplied by 3/6? Okay? So again, I could take 17 times 3 and get a numerator. I could take 34 times 6 and get a denominator, but I'm going to have huge numbers, and then I'll have to simplify this huge fraction. Much easier to look and see if I can pre-simplify it. I immediately see a 3 and a 6. I know I can divide top and bottom by 3. 3 divided by 3 gives me 1. 6 divided by 3 gives me 2. Single line, mark the new number there. So now I've already simplified this. Let's see if I can do anything there. You might look at those and say, well, I can't really do anything to 17/34 until you realize 17 times 2 is 34. So I can divide top and bottom by 17. 17 divided by 17 is 1. 34 divided by 17 is 2. So now everything's gone. Only these red numbers are now present. So 1 times 1 gives me 1. 2 times 2 gives me 4. 1/4. So again, I want to stress, you could do the multiplication and the simplification and you'll get this, but see, I'd have to deal with all this multiplication. And then I would have to simplify the answer. If I do a little bit of pre-work, then my answer is going to come more quickly and easily, really. All right, let's go and work a little bit different. Let's look at 12 times 5/6. The number 12 times 5/6. Now you might look at this and say, well, he hasn't told me how to do this because I've been dealing with fractions and this is not a fraction. But anytime you see a whole number, anytime, and you're dealing with fractions, you should always rewrite that fraction, rewrite that number as a fraction, 12 over 1. So that's what 12 is, 12 divided by 1, right? And so here I have 5/6. Don't forget, fractions in general are just division. That's what they are. They're a shorthand way of writing division. Way back in the beginning, when I said 6/12, it's part over whole, it's also representing division. 6 divided by 12 gives us 1/2, or 0.5 in your calculator. 12 divided by 1, that's a fraction that gives us 12. Fractions in general are division symbols, basically, is what they are. So here I have 12 over 1 times 5/6. And I'm trying to pre-simplify this. I'm noticing the 12 and the 6 are easy targets. I can divide both of these by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. Now I can't do anything else with the 5 or anything, so I'm basically done. 2 times 5 gives me 10. 1 times 1 gives us 1. Now I can circle the answer and say 10 over 1, but don't forget, fractions are just division. So 10 divided by 1 is 10. And that's the answer. So if you take 12 and multiply by 5/6 in your calculator, you'll just get a number 10. That's going to come out the answer. Now let's do one more in this little series here on multiplying fractions. 10 21st multiplied by 14. Same exact deal. I've got a fraction times a number, but just to make it easy on yourself, make it a fraction multiplied by a fraction. Then you can visualize it easier, 14 over 1. Now let's try to do some pre-simplification right here. Looks like it's not going to be possible, but on the top I have this 14 and the bottom I have this 21. If you think about that hard enough, you can divide by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. Now, there's nothing else I can do as far as pre-simplification. So what I'm going to have is 2 times 10 gives me 20. 3 times 1 gives me 3. So I have 20 over 3. And this again is an improper fraction, 20 over 3, but we're just going to leave them like that for now because really, you know, I know that you've been in math up until now. You've learned about mixed fractions and, you know, in the pre-algebra tutor I actually taught quite a bit about how to convert these back to mixed fractions. But in algebra, you don't worry too much about mixed fractions too much really. If you get a fraction, even if it's improper, you generally just leave it like that. So it's not that important to convert back and forth. So I'm not going to emphasize that too much. If you're confused about how to, if you want to convert back to a mixed fraction where it's like 3 1/3 or something like that, then you could certainly go and review some of the pre-algebra material that'll give you that foundation. And we'll do a little bit later on as well. But certainly in algebra, the focus is not going to be on doing that. If you get an improper fraction, you'll leave it that way. Now, we've covered quite a bit of material when you think about it because we've introduced what is a fraction, we've taught how to simplify fractions, and we've taught you how to multiply fractions. And I promised you that division of fractions is also not hard, and I'm going to live up to that right now. It's actually easier than adding or subtracting them. Let's go ahead and divide fractions. Divide fractions. All right, so let's do one like this. Let's say we have 3/5 divided by 2/3. All right, so we have a fraction and we're dividing it by another fraction. Now, let me show you a different way to write this. Not so much because it's better or because it's proper, just because in your algebra books you'll probably end up seeing it this way eventually, and I don't want you to be confused. This division symbol, the bar with the dots, is what you've really learned up before algebra. But when you get into algebra proper, which is what we're going to study in this course, you don't use that symbol too much because it gets in the way of all your variables and everything else. So if you want to represent division, this is okay, but another way to write it would be like this, and you'll see it's not a big deal. 3/5 divided by 2/3. Now see, it looks a little funny at first until you realize this is just a big division bar, which is like a fraction bar. So you have 3/5 on top, 2/3 on the bottom. Okay, so when you think of it this way, it's kind of nice because in order to do this division, all you have to do is take the first fraction, 3/5, and you change this division into a multiplication. You put a multiplication symbol, you take the bottom fraction, you flip it over, and make it 3/2. And then you do the rest of the problem exactly how we've been doing it just a few minutes ago. So really all, and this is very important, all fraction division simply becomes multiplication. That's all it does. And you already know how to do multiplication because we've just been doing it. So all you do is you take the first fraction, flip the second one over, and multiply them. And that is going to give you the answer to this division problem. So we look at this. We try to pre-simplify. I don't see anything I can divide by, so I'm just going to do the multiplication. 3 times 3 is 9. 5 times 2 is 10. I can't simplify this anymore, so I circle it. 9/10 is the answer. Now, when you're younger than you are right now, and you learn long division, division of numbers, that can get very tedious and difficult at first. There's a lot of steps, remainders, and all that stuff. With fractions, it's really easy. All you do, take the second one, flip it over, multiply. And that's it. So let's work another one. Let's say we have 3/4 divided by 6/5. Okay? Now, I've introduced this to you guys just to kind of show you what that is, but you don't really need to write it like that. I was just mostly introducing it. You can just do it like this. 3/4, change this division into a multiplication, flip the second fraction over. 5/6. All right? Now I try to pre-simplify. Always get in the habit of doing that. I have a 3 and a 6. 3 divided by 3 is 1. 6 divided by 3 is 2. There's nothing else I can do on top and bottom, so 1 times 5 gives me 5. 4 times 2 gives me 8. 5/8. And that is the answer, 5/8. Okay, next problem, change colors a little bit here. Let's say I have 2/13 divided by 8/13. Okay, so let's change it into our multiplication. First fraction stays the same, 2/13. Change this to a multiplication symbol. Take the second fraction, flip it over. 13/8. And then I should immediately start looking to see if I can pre-simplify. I see a 13 and a 13. I know I can cancel them. Another way to think about it is I can divide top and bottom by 13. 13 divided by 13 gives me 1. 13 divided by 13 gives me 1. I see a 2 and an 8, so I know I can divide by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. 8 divided by 2 is 4. So I have everything totally simplified. These numbers are gone. 1 times 1 gives me 1. 1 times 4 gives me 4. The answer is 1/4. 1/4. And you would get exactly the same thing by doing 2 times 13 on the top and 13 times 8 on the bottom and simplifying, but 13 times 8 is going to give you a really big number, and then you're going to have to simplify it on top of all of that. So it's a little bit cumbersome. Let's just do a few more and just get our skills just to make sure they're rock solid with this. If I have 21/35 divided by 3/14. When I have division, I always rewrite it. So rewrite the 21/35, change it into multiplication, take the second one, flip it over. 14/3. And I can simplify this. I have 21 and I have a 3. I can divide by 3. 3 divided by 3 is 1. 21 divided by 3 is 7. And I have exactly the same thing going on right up there. I divide the top and the bottom. Now, let's say I don't realize that I can also simplify this. I know that I can simplify this further, right? Because I can divide by 7. I can divide by 7 on the top and by 7 on the bottom and simplify this further. But let's say I don't get that. Let's say I don't remember that. So let's go ahead and do it. 7 times 14, you'll do that by hand or in your calculator, and you'll get 98 on the top. On the bottom, 35 times 1 is 35. So you're left with this, and then you'll have to look and see if you can simplify that. And if you play around with that long enough, you'll realize that you can simplify it by dividing by 7, right? 98 divided by 7 is 14, and 35 divided by 7 is 5. So the answer is 14/5. So I guess what I'm trying to say is that you try to pre-simplify as much as you can. If you do all of the pre-simplification possible, then the answer that you get is always going to be totally simplified. If you miss one and just go ahead and compute the answer and then simplify the answer, you're going to get exactly the same thing. You're going to get the right answer. It's just that you know, you might have to do some simplification at the end, which is what we did here. All right, now let's go and do another one. Let's do 6 divided by 3/14. 6 divided by 3/14. Okay, so we're going to write this. 6, we're always going to write as 6 over 1. We're going to change this division into a multiplication. We're going to flip this guy over, 14/3. Okay, next we're going to simplify 6 and 3. 3 divided by 3 is 1. 6 divided by 3 is 2. We're done with the simplification. 2 times 14 is going to be 28. And on the bottom, 1 times 1 is 1. Don't forget, fractions are just division, so 28 divided by 1 is just 28. So if you were to take this in your calculator and take 6 divided by 3/14, you would just simply get 28. We'll do one more of this problem type, and then we'll work on some more other skills. Let's do 42 divided by 30 divided by 7 over 1, which is just divided by 7, by the way. So we'll just do 42/30 right here, change this into multiplication, and then flip this over to 1/7. Okay? Now let's see, can we do any simplification? But before, we can work with 42 and 7. 7 divided by 7 is 1. 7 divided by 42 is 6. So we're done with that. Multiply the top. 1 times 6 is 6. 30 times 1 is 30. Now look at that. We actually still have some other simplification that we can do. 6 and 30. I know I can divide the top by 6. 6 divided by 6 is 1. 30 divided by 6 is 5. So it's 1/5. And that's the answer, 1/5. Now, how did we do that? Why did we not get the fully simplified answer when we did this? It's because we missed something here. We simplified the 7 and the 42 to give us the 6 and the 1, but I should have noticed right here, I have a 6 and a 30 here. So I would have been able to simplify this a little bit more here before doing any multiplication. But like I'm saying, even if you forget to do it, just do the multiplication, simplify your answer, and you're going to be on the right track and get the right answer. So again, we've learned how to multiply fractions. We've learned how to divide them, and you see there's really no difference. You just take that division, flip it over, make it into a multiplication. Next, what we're going to do is work on addition and subtraction of fractions. A lot of people get confused with it, but I'm going to show you a way that's going to be very, very simple for you, and so you're not going to stress out, not going to worry too much about it. So the most important thing when we're dealing with addition and in subtraction of fractions, and this is very important, so make sure you remember this. The only way you can add or subtract fractions at all is if those bottom numbers, those denominators, are the same. You cannot add fractions unless those two denominators are the same. I'm going to say it one more time because it's so important. You cannot add or subtract fractions unless those bottom numbers in those fractions are the same number. It did not matter in multiplication and division, and that's why they're easier. You don't have to worry about what the numbers are. But when you're adding and subtracting, you always have to look at the denominators of the fractions. Okay? So let's take a good example of that. 3/5 plus 3/5. Okay? So we have two fractions, 3/5 plus 3/5. What I'm trying to say is that in order for you to do this addition, these two numbers on the bottom, the 5 and the 5, they must be the same. So if the fractions that you're given already have the same denominators, which are the same bottom numbers, then it's easy. I'll show you how to add them. If the numbers are different on the bottom, then you have to do one step before you can add them. And that's really all there is to it. We'll get to that when we get to it. But let's first do this one. If they are the same, all you do is you add the top numbers. 3 plus 3 is 6. And you do not add the bottom ones. You just keep the bottom one. So you're going to get 6/5. You can try to simplify that, but in this case, you can't simplify it anymore, so you're done. Let me say it one more time. You add the top numbers to get the new top number. The bottom numbers, you do not add them. You just keep the bottom numbers. Because really what I've got here is 3/5 of a pizza. 3/5 of a pizza. My answer is 6/5 of a pizza. It has to be in terms of the original denominator, and that's just the way fractions work. Okay? So the answer in this case is going to be in terms of how many fifths of a pizza have I given away. I've given 3/5 to Tommy, given 3/5 to Bobby. Altogether, I've given away 6/5. That's why it has to be in terms of that same denominator. Now, let me get another one here. Let's say I've got 4/13 minus 3/13. So I'm subtracting, but the same thing holds. These bottom numbers are already the same, so I'm okay. I just subtract the numerators. 4 minus 3 is 1. I do not subtract the bottom ones. I just keep it. So I have 1/13. And that's already simplified. Okay? So I just give you two examples, but that's how it works. You keep the bottom number, you subtract, or you add the top. You simplify the result. Very, very simple. Now here's where most people start to get confused. What if I give you 1/6 plus 1/24? And I say add those fractions. Now things start to get a little more, I don't want to call it complicated because it's not hard, it's just different. Because these bottom numbers are not the same. They're not the same. So I've already told you I cannot add them unless they are the same. So anytime you try to add or subtract fractions, the bottom numbers are different, you must make them the same by any means that are legal to you. And I'm going to teach you those ways. And if you can do that, then you can add them, right? So let me ask you this. I already told you that you can do anything you want to the top and the bottom of a fraction as far as multiplying and dividing. Anything you want, as long as you do it to the top and to the bottom. So if I wanted to change this denominator into a 24, then all I would do is multiply by 4, right? If I wanted to multiply this bottom number by 4, I would get 24 for my new denominator. But the only way to make that legal is to also multiply the top by 4, okay? So if I do that, I'm going to get over here, I'm going to get 4/24 over here. Now how did I get, and I'm going to add to that, let me just write this down, 1/24. I've transformed this fraction into this over here. How did I get from here to there? All I did was I took 1/6 and I multiplied the top by 4 and I multiplied the bottom by 4. And that's how I got there. 1 times 4 is 4. 6 times 4 is 24. You can do anything you want, so you just need to find one of these numbers that you can multiply by to give me the same denominator as the other fraction. So here I have two fractions with the same denominator, so I'm good now. To get the answer, 4 plus 1 is 5. I do not add the bottoms, I just keep them. 24. 5/24. And that's the answer. It's already simplified. You always look to see if you can simplify it more, but it's already done, so you're finished. So that's really all it amounts to. This is what we call in fractions finding the common denominator. It has such a fancy sounding name, but really all it means is figure out a way to make these bottom numbers the same and do it legally, and then you can add the fractions. So we're going to do a bunch of problems here to make sure that you are totally comfortable with this guy, with this idea. So what I'm going to have here is 3/5 plus 2/3. Now this is even a little bit more complicated, but the same exact goal is what I'm trying to do. I need to get these numbers on the bottom to be the same. All right? I can't just work with one fraction because if I multiply 3 by something, I'm never going to get 5. I can't just work with this fraction because multiplying something times 5, I'm never going to get 3. So I need to be a little more creative here. But let me show you what we can do. Let me go down below here. 3/5, all right, and then plus 2/3. Let me ask you what's going to happen. If I multiply the top by 3 and the bottom by 3, I have changed nothing in this fraction. If I multiply the top by 5 and the bottom by 5, I have changed nothing in this fraction because I'm totally legal here. When I do this, 3 times 3 is 9, 5 times 3 is 15, plus 2 times 5 is 10, 3 times 5 is 15. Now I have common denominator. So you see, that's all you're doing. You can multiply a fraction by anything you want in the top and the bottom as long as you do it to the top and the bottom. So you're free to choose anything you want. I'm choosing what's easy for me. I know if I multiply by 3, I'm going to get 15. I know if I multiply by 5, I'm going to get 15. So I just need to do it to the top as well, and I get this. So when I continue on, 9 plus 10 is 19/15. And that's already totally simplified. There's nothing more to do, 19/15. So keep that in mind when you're adding or subtracting fractions. If the denominators are the same, you just do what we've shown how to do and add or subtract them. If the denominators are different, then you just need to make them the same. By any means, that's legal, before you can add or subtract these fractions. Now what we're going to do now is erase this board that I filled up and continue working some problems to give you some practice. Okay, our next problem is 9/4 minus 5/6. So I've got two fractions, two totally different denominators. I know that I'm not going to be able to work with just one of them because there's no way I can multiply 4 by anything to give me 6. There's no way I can multiply 6 by anything to give me 4. So I'm going to have to do something to both of these fractions. So let me rewrite them. 9/4 minus 5/6. What can I do? I mean, you're really given any latitude that you want to do. But when I look at 4 and 6, I start to immediately think of the number 12 in my head because I know that 4 will go into 12. And I know that 6 will go into 12. So if I multiply this by 3, and then multiply, of course, the top by 3 to keep it legal, and if I multiply this times 2, and then multiply the top by 2 to keep it legal, then I'm going to get 12 for the new denominator in both cases. So I've got the same number in the bottom. 9 times 3 is 27 on the top. Of course, I get 12 on the bottom, minus 10 on the top, and then I've got 12 on the bottom. So I've achieved my goal. I now have 12 in the bottom. Now, in order to actually subtract them, I just subtract the top. What's 27 minus 10? You'll get 17 over 12. And that's already simplified. 17/12. There's nothing else to do. You see, it's very easy. Common denominators give so many students trouble. I think it's the way it's explained. If you just give you guys the freedom to do what you want to give these denominators the same number, you'll be fine. Let's look at 7/10 minus 1/14. Looks like a very scary problem prior to today. But what we need to do is figure out a common denominator. What can we multiply these to sort of make them the same thing? I can choose anything I want to do, but you know, if you play with it enough and you think about it enough, if I multiply this one by 7 on the bottom, I'm going to get 70. I've got to do it on the top to make it legal. If I multiply this one over here by 5, I'm also going to get 70. Now, you may not see that right away, and that's okay. You just have to play with it a little bit. You'll get experience and practice with it. But by and large, all I'm doing is picking a number so I can get the same number when I multiply, or I can get the same denominator. 7 times 7 is 49, and this is 70 right here. 1 times 5 is 5, and then I have 70 here. Okay, so what is 49 minus 5? It's 44 over 70. And then that's the answer, right? But you need to always look and see, can I simplify this more? I know I can divide by 2. What's 44 divided by 2? It's going to give me 22. What's 70 divided by 2? It's going to give me 35. And if I look at this, I don't believe I'm able to simplify that anymore. So it looks complicated, but it's really the same thing. And that's really going to conclude. I could do 20 more problems, but really they're not any more difficult. They're not any more complicated. All you're doing is looking at these denominators, you know, and trying to come up with some number to multiply each one of them by so that I can get whatever, any number. It doesn't matter what the new denominator is. Try to get it, okay? And then, of course, to make it legal, you have to do the same thing to the top. Do your subtraction, and then always check to see if you're fully simplified. If you do those steps, you'll always get the right answer. Now, what I want to do here before I close is just talk a little bit about mixed fractions. You don't use mixed fractions too much in algebra, but this is a primer, so we'll talk a little bit about them. Up until now, we've always represented fractions as one number over another number. And I've always kind of explained that as usually you're talking about dealing with less than 1. Like if you have half a candy bar, that's why we use fractions. 1/3 of a candy bar, 1/8 of a candy bar, right? 1/16 of a candy bar would be a really tiny piece of a candy bar, 1 out of 16 pieces, right? But if you ever see something like this, 4 3/5, this is what we call a mixed fraction. What it means is I have 4 whole pizzas plus 3/5 of another one. That's what it means. A mixed fraction is nothing complicated. It just means I have this many whole candy bars plus 3/5, which is less than 1, of another piece of a candy bar. That's what it means. That's all it is. So if you ever see a problem where you have to add these guys to something like 3/5, this stumps a lot of students because you have this weird number out front, you're not really sure how to handle it. The easiest way to probably do that is to convert this mixed fraction to an improper fraction. It's probably the easiest way to handle it. And the way you do it is like this. And we've covered all of this in the pre-algebra tutor and all of that as well, but just as a primer. You take the 5 on the bottom, multiply by 4. In this case, it's going to give you 20. You add in the top number, so you're going to get 23. That's going to be the new top number, 23. And then the bottom number always stays the same. So that's it. You've converted that back to an improper fraction. Notice the top number is bigger than the bottom. Any of those examples before where the top number was bigger than the bottom, it just meant that I had more than one of something. In this case, it's 4 3/5, same thing as 23 over fifths. I just had more of a pizza, plus a fractional part left over. Okay? But to add them, it's just much easier to convert back this way. So 4 times 5 is 20, plus 3 gives me the 23. Always keep the bottom. And now I need to add the 3/5 to it. And now the same rules pick up. I mean, there's nothing different. 23 plus 3 is 26. And on the bottom, you still keep the number, which is 5. So 26 fifths. Now, again, in algebra, you're almost always going to leave it like this. But, you know, occasionally a teacher might ask you to take this improper fraction and convert it back into a mixed fraction. And that's very easy also, because don't forget, fractions are really just division. So what we have here is 26 divided by 5, really, is what we have. How many times can 5 actually go into 26? Well, you think about it, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, getting closer, 5 times 5 is 25. That's pretty darn close. If we do 5 times 6, that's 30, and that's too big. So we go back to 5 times 5. So it'll go in 5 times. We draw a big 5 out in front, right? So it goes in 5 times. 5 times 5 is 25. But we had 26 things on top, so 26 minus 25 is 1. So we had a remainder of 1. We always write it over 5. So it's 5 1/5. I'll say that one more time. You're doing the division, 26 divided by 5. It goes 5 times, but the remainder is like 1 left over because 5 times 5 only gave us 25. We didn't quite get all the way up to 26. We had 1 left over. We take that 1 that was left over, we write it over 5. And if you want to check your work, you can always go backwards. 5 times 5 is 25, plus 1 is 26 over 5. So it checks. Okay, you can always go backwards and check in algebra, almost always. What if you had 3 1/3 minus 1 2/3? Okay, then again, it's going to be easier for you just to convert both of these mixed fractions to improper fractions. So we'll work with this one first. 3 times 3 is 9, plus 1 gives us 10. Always keep the bottom number of 3. Okay, over here, 1 times 3 is 3, plus 2 gives me 5. Always keep the bottom number, which is 3. So now I have this exactly in a form that I can solve it because I've been doing this all day. 10 minus 5 is 5. Always keep the bottom number of 3. 5/3 is the answer, and you can just circle that. But if your teacher, for some reason, wants you to convert it back to a mixed fraction, you can just do the division. How many times will 5 go into 3? Well, it'll go 1 times 3 is 3. 2 times 3 is 6. That's too big, so it can only actually go in 1 time. How many is left over? Well, 1 times 3 is 3. I was trying to reach 5, so I have 2 left over. And I always write it over the original denominator. So it goes in 1 whole time, remainder of 2, always make it over the original guy. So 1 2/3. And if you're unsure if you've done that right, just check it. 1 times 3 is 3, plus 2 is 5, 5/3. And you've gotten the right answer. Okay, this will be our final problem. A little bit more complicated, but not a big deal. 3 3/4 minus 2 1/2. So again, we're going to do the subtraction, but let's first convert these to improper fractions. So what we'll have is 3 times 4 is 12, plus 3 is 15. Always write it over the original denominator of 4. So 15/4 minus 2 times 2 is 4, plus 1 is 5. Always write it over the original denominator of 2. So here we want to do this, we've converted them, we want to do the subtraction, but we don't have common denominator. We always have to have the common denominator. Notice in this problem, it was constructed so we already had a common denominator, so we just did the work. Here we had a common denominator, so we just did the work. But here, when we get to this step, we don't have a common denominator, so we have to make them common first. So let's go ahead and rewrite this as 15/4 minus 5/2. How can we make the denominators the same? Well, here I have 4 and 2. If I just multiply this denominator by 2 and, of course, do the top to make it legal, I'll get 4 on the bottom, which is going to be the same as my other guy. So 15/4 minus 5 times 2 is 10 over 4. Now I've got a common denominator. So I do the subtraction. 15 minus 10 is 5/4. And that's the answer. 5/4 is the answer. But again, if your teacher or if your worksheet or whatever wants you to write it as a mixed fraction, since the top is bigger than the bottom, you can do that. How many times will 4 go into 5? It's only going to go 1 time. How many is going to be left over? Well, 4 goes into 5, 1. It's only got 1 left over because 4 is 1 less than 5, and you always write it over the original denominator, so 1 and 1/4. If you're unsure if that's right, just check it. 1 times 4 is 4, plus 1 gives me 5 over 4. So it does check out and gives me the right answer. So we have concluded this section. We've covered a tremendous amount of material, and I really hope that it serves as a great primer for you because, you know, truth be told, there's a rule of thumb. If a student really understands fractions, then they probably won't have any problems understanding anything else in algebra, geometry, or anything that follows. All right, because fractions are just so useful and used in every class that you're going to use from here on out. So really make sure that you understand all of this. If you think you need more practice above and beyond this, go grab the worksheets that are available for this course. Go grab the pre-algebra course, which has even more examples. Make sure you understand fractions. We've talked about simplifying fractions. So they may look different, but they represent the same amount of stuff. When we multiply divide fractions, we don't worry about common denominators. We just do the multiplication, if it's multiplication, and simplify the result. If it's division, all we do is flip that second fraction over and change it into multiplication, and then do our work. If we're adding or subtracting, the denominators must be the same. If they are, you just do the math, and if they're not, then you may have to do a little step in here to make the denominators, like this one, the same, and then try to simplify your answer. And then finally, we talked about mixed fractions and improper fractions, converting back and forth, and also how to do some simple math with fractions. I didn't do a problem here, but if you had multiplication or division that involved a mixed fraction, you would treat it the same way. You would just convert it to an improper and then do the multiplication or division. So there's no real secret tricks here. It's just a matter of really having a great solid foundation. And you know, trust me, you really want to make sure you understand it, because later on when we get into equations with a big fraction bar and lots of stuff on the top and lots of stuff on the bottom, you don't want to be scared off by that. The only defense you have against that is making sure you understand this. And trust me on that, it'll really help you for years and years to come. So practice your problems, watch this section a few times, roll up your sleeves, get some confidence, and I guarantee you it'll help you in this class and all of your future math classes.